Alright, so Wednesday of this week. So looking ahead, you've got a week 8 homework. I want to say, is it pink this week? Purple? I don't remember. What color is homework this week? Purple? Orange? Roy G. Biv? Whatever color it is. Do this Friday. Okay? Okay? And you will have a formative this week, Friday. Okay? So a twofer, homework and a formative. Don't forget, too, that all of your homework, all of your formative type stuff, okay? So that includes all of your homeworks and anything that's on a green formative sheet, okay? All of those are fixable, meaning if you didn't get 100%, you can turn those in to get 100%, okay? Okay? So fix those. That came up a couple of times last night in conferences. They're like, wait, what? They can fix them? I go, yeah. Formatives are fixable. Okay? Right? So definitely want to do that. Because I want you to get as many points as you can, because that's going to make it easier on you in the long run. Okay? So a warm-up today. Factor this polynomial completely, please. All right. Greatest common factor, first thing we look at, is there one? 2x squared. Okay. So 2x squared is going to be my greatest common factor. If I pull out a 2x squared, what's left over in my first term?
4x squared.
4x squared. What's left over in my second term?
9.
9. Okay. Now, is that factored completely? Why not? Because it's a binomial and it's a minus sign. So we should look for either the difference of perfect squares or the difference of cubes, right? Let's take the one that it's not right away. Is it a cubic minus a cubic? No, because the square tells me it's squared. Okay, so looking at difference of perfect squares. Is 4x squared a perfect square term? Because 4 is one of our perfect squares. It's on our list from Monday. And x squared is an even exponent, so it is a perfect square. Is 9 a perfect square?
Yeah.
Yes. Okay, so it is a difference perfect square, so it can be factored more. Okay? That's what the word completely, I scrolled down too far. That's what the word completely means. We gotta go, yes, we factor. Okay? So if I would have just said factor, this would have been an answer. Okay, because you did technically factor. Okay? But factor completely says that we're going to write it as 2x squared times 2x minus 3 times 2x plus 3. If you went plus 3, then minus 3, that's fine too. Order of those doesn't matter. Good? Love it. Okay? So the last way, so on Monday, we factored with GCF. That was our first way. Then we factored by difference of perfect squares. That was our second way. Then we did trinomial factoring, the 2 parentheses method. And we did cubics. So we did 4 methods on Monday. Today I'm going to give you the last method of factoring, which is factoring by grouping. Okay? So factoring by grouping is only used if you've got 4 or more terms. Okay? So that's the easy way to see it. Okay? If you've got a lot of terms, more than 3, you're going to use grouping. Okay? And how it works out is it is simply 3 GCFs. Okay? you're gonna 1 GCF the first half. You're going to cut the polynomial in half. And you're going to GCF the first half. Okay? Then, you're going to GCF the second half. Okay? And then at the very end, you're going to GCF both halves. Now, it's kind of weird to write it down that way, but in practice, much easier. Oops, I did do 2 of them. All right, well, let's go like this. Okay. So, step number 1 says I need to GCF the first half. So here is the first half of my equation. Looking just at the green box. What is my greatest common factor? 1. X squared. 1 in terms of the number, x squared in terms of the variable, so we'll call it just x squared. What is left over? X minus 7. With me on that. Okay. Step 2 says I need to GCF the second half of the original. Greatest common factor, 8. Okay. Positive or negative? Positive. Now, just so you know, that sign, the positive or negative, is going to go along with this sign right here. So whatever that neat sign is on the second half, that's going to be that one right there. What's left over? X minus 7. Okay. Now, what I'm going to do is I'm going to GCF that one. Notice that in both the green and the blue, they have an x minus 7 part. So that is my GCF. I'm going to pull x minus 7 out. What's left over? X squared plus 8. Yeah. And then I look at that x squared plus 8, and I say to myself, self, can I factor that more? Answer, in this case, don't factor it all the way. So then we're done. Yeah. Kind of remembering my old memories, maybe not so good memories, but old memories are starting to come back. Okay. You try that one. GCF first half.
19 squared.
9t squared. I like it. What's left over?
3t minus 5.
Plus 5. Wait.
Plus 5. Plus 5.
No. Okay. GCF second half.
T.
No. Because the 5 doesn't have a t. Negative 1. And I'm going to go with negative 1 because that first sign is negative. Okay, so I got to factor out a negative 1. And then what's left over? 3t plus 5, because I also want those two parentheses to be the same. Okay? Both now have a 3t plus 5. And then that leaves me with 9t squared minus 1. Can I factor 3t plus 5 even more? No. Can I factor 9t squared minus 1? Yeah. 9's a perfect square, right? T squared is a perfect square, so 9t squared is a perfect square. We have a subtraction sign. That should be the kicker right there. In your brain, when you see a subtraction sign, that should automatically, I gotta check for the difference of perfect square. And 1 is a perfect square. So yes, this can be factored even more. 3t plus 5. 3t minus 1. 3t plus 1. Questions on any of that? Awesome. Alright, let's shift gears now. Where we are going with this factoring stuff is I want us to get to this. Okay? We're done I shouldn't say we're done factoring, but we're done factoring just the factor. Okay? We really want to factor in order to solve. Okay? That's what we want to do. The fundamental theorem of algebra says that the degree of a polynomial, anybody refreshed by memory, what is the degree of a polynomial?
It's the biggest, what's it called? Coefficient?
Not coefficient.
Exponent?
Exponent. The biggest exponent. Okay? So the biggest exponent in our polynomial tells us how many solutions we need. Okay? So if I go back to the 3 examples that we've had so far, how many solutions would I need in number 2? How many answers? Zeros, solutions, roots. How many would I need to get? 3, because the degree is 3. In number 1, how many would I need to get? 3. Okay? And I don't stop until I get those 3. Back in this warm-up, how many answers do I need to get in the end? 4. Okay? Because that's the degree. So that's one of the nice parts about the degree, is that it tells us how many answers. Oh, I get it. He's being a nerd, I get it, but you don't gotta flip them off. If you're gonna flip them off, just flip them off. You know, don't hide it here, just flip them off. I mean, come on. Okay? Alright? You tell, I've been flipped up so many times in my life. Doesn't even faze me in there. Okay? The old eyebrow one, you know, this is my favorite. Yeah, the makeup, yeah, you pop open the makeup, and then you apply the powder with another one too. Yeah. I can hear the phone calls now. Yeah, I did. Video. Okay. Right. So for today, we're only going to find real solutions. Yeah. Only real things. None of this odd stuff. Okay. None of this complex stuff. Actually, that's not next week. Short week. Week after. Okay. But it is coming. It is coming down the road. Okay. So we will have our dear old friend to be used, the quadratic formula. I know, I'm sorry. I'm sorry to be the bearer of bad news. But if you don't have the quadratic formula memorized, you should probably, at this point in time, just get it memorized. It works. It works on all of them. Okay? And it for sure works when you can't factor. I know, I'm mean. I am the meanest. Nope. come up with a plan. Let's work our plan and plan our work. Yeah? Everybody got the quadratic formula written down that needs to have it written down? Okay. Alright, come on. There we go. Step number 1 says, we gotta get our equation equal to 0. Okay? If you don't do that from the start, you're gonna be lost right away. Okay? So come through the weeds and get yourself equal to 0 right off the start. Find your center, your zen, if you will, is equal to 0. So in this equation, or in this example, number 3, what would be the first thing that you do? Add 36x to both sides. Okay. What would my other option be that might sometimes come into play? Could move all the left side, move all left side over to the right side. Right? Now, big fan, ginormous fan of having that lead coefficient. Remember that lead coefficient is the coefficient on the degree term, the biggest exponented term. Having that be positive. So that's going to dictate which way you go with your stuff. Okay? It doesn't matter which side you get equal to 0, okay? But you want that lead coefficient equal, or that lead coefficient to be positive. Okay? So we're going to add 36x to both sides. So that's going to then give me 4x to the 5th minus 40x cubed plus 36x equaling 0. Then, step number 2. You are going to factor until you cannot factor anymore. And then you're going to factor some more because we want you to factor it all the way up. Okay? Now, that's going to bring in all 5 methods of factoring. Might even bring in multiple methods of factoring into that scenario. Okay? So if I'm looking at 4x to the 5th minus 40x cubed plus 36x, do I have a greatest common factor? 4x. Okay. What's left over? X to the 4th minus what?
8x.
Not 8x squared. 10x squared. Plus 9. Can my trinomial be factored? 2 numbers that multiply together to be positive 9 and add to be negative 10. What? What do you got? Negative 1 and negative 9. So then this would become 4x times x squared minus 1 and x squared minus 9. Side note, how many answers do we need in the end?
5.
Gotta come up with 5 answers. Okay? Right? Do either one of those binomials, or can either one of those binomials be factored? Both of them? Because they're both perfect squares minus perfect squares, right? So then this would become 4x, x minus 1, x plus 1, x minus 3, x plus 3. Can I do any more factoring? No, we factored completely. We factored all the way down. Okay? Now, what we're going to do is we are going to set our factors equal to 0 and solve. This would be where you might have to use the quadratic formula in this set. Because if you're doing a cubic, remember we factor a cubic, that quadratic or that second trinomial in a cubic isn't factorable. So if we need to solve it, that would be using quadratic formula. Okay? So with that being said here, I guess I gotta extend my page and then just go back up. So with that being said here, we would say 4x equals 0. X minus 1 equals 0. X plus 1 equals 0. X minus 3 equals 0. X plus 3 equals 0. And then we'd have to solve all of those. So this one would be x equals 0. X equals 1. X equals negative 1. X equals 3. X equals negative 3. How many answers did we say we needed?
5.
5. How many answers did we end up getting?
5.
5. Okay? So if you choose to list them all out, or if you choose to use the plus minuses, either way, you still get all 5 answers. Questions, comments, concerns, clarifications? Let's try this one. Find me the real solutions. Step number 1.
Add 4x squared.
Add 4x squared both sides. GCF? What are you going to do? What's the GCF? X? My trinomial, can that be factored? Two numbers that multiply together to be negative 10 and add to be positive 4. 1 and 10 subtract to be 9. 2 and 5 subtract to be 3. So that's not going to work. So are we factored completely? We're factored completely. You did one step ahead. Yeah, we're factored completely. So then we have to set our factors equal to 0. And then what? Now we're going to use the quadratic formula. Okay? So x here is going to equal the opposite of b, plus or minus, big square root, b squared minus 4 times a times c, all over 2 times A. So that's going to be 16 minus negative 40. 16 minus negative 40 is 56. Can the square root of 56 be simplified? Is there a perfect square factor that goes into 56? Is there a perfect square factor that goes into 56? Is there a perfect square factor that goes into 56? We have 4 goes into 56. 4 is perfect square. How many times does 4 go into 56? Anybody? 14 times. Okay? A bad 14. Square root of 4 then is 2. So then this would become negative 4 plus minus 2 square roots of 14 all over 2. Yes, you are going to, if you use the quadratic formula, you're going to have to simplify your radicals. Outside numbers are the only ones that I can look at. Negative 4, 2, and 2. Is there a common factor that goes into all 3 of them? Into negative 4, 2, and 2. BFG? 2 goes into all of them, right? So what is negative 4 divided by 2? Negative 2. 2 divided by 2, 1. And 2 divided by 2 is 1. So we get x equals that. So in the end, we said we needed 3 answers, right? Because it was a cubic. So my 3 answers are x equals 0 and negative 2 plus the square root of 14 and negative 2 minus the square root of 14. Are my 3 answers. Okay. One more to do, and I'm going to have you do this one on your own. Find me the real solutions to this one. If they're imaginary, I don't want them. Okay? So, 4 terms, definitely. First off, we got it equal to 0. Yes, that's good. Step 1's done. 4 terms, got to GCF the first half. So that's going to be an x squared. And that's going to leave me with an x plus 3. GCF the second half. That's going to be a 5. And that's going to leave me with an x plus 3. And that's still going to equal 0. So then that factors all the way down to be x plus 3 times x squared plus 5 equals 0. Factored completely. Love it. Then I set my factors equal to 0. X plus 3 equals 0. So x is going to be negative 3. X squared plus 5 equals 0. How can I go about solving that one? 2 different ways that we could solve that one. Because it's not factorable. what are two different ways that we can solve that? We could use the quadratic formula, but b would be 0. Yep, that's one way. What's the other way? That's a little quicker. What? Oh, so we move the 5 over and then square root. Yep, okay. So if I move the 5 over, I would get x squared equals -5, and then I can square root, right? But if I'm square rooting in a solving situation, what do I have to bring into play? Plus minus, because remember, I need to get 3 answers here, right? So here's one answer, which means this has got to produce 2 answers. So I would have here x equals plus or minus the square root of -5. It's imaginary, right? And what did the directions say? All real numbers. So this one does not count yet. In a couple of weeks, it will come. But so for right now, it's just -3. Okay? Because we're only looking for reals right now. If a guy had a calendar, on 18 different numbers, imaginaries is 3/6, which is Monday the 30th. So not next week, but the week after. Then we'll bring it. Okay? So, remainder of the time, you can now be working on your worksheet for this week, which we have decided is gold. None of the colors that we had said. Okay? So you, right now, can do the whole worksheet. Like you have all of the tools in your toolbox to do the whole worksheet. Tomorrow is just going to be some more practice problems with factoring and solving and all that fun stuff. And then Friday will be your formative.